Imagine that you need to perform some operation as a variable takes on all of the values from 1 to 100. One option would be to add a line of code for each individual value, but that would be a tedious task and make maintaining the code difficult when you needed to increase or reduce the number of items. Most programming languages include some way of looping through a range of integer values, incrementing or decrementing the index value at each iteration. And C# provides the for loop, with a really simple syntax for iteratively looping. So the for loop lets you do things like run code repeatedly as an integer value takes on a value between two endpoints. You can increment the looping variable by 1. You can skip the looping variable values by incrementing the looping variable by 2 or 3 or whatever. You can also loop backwards by setting the increment to -1 or some other negative number. And you can also nest loops, providing support for multidimensional data. So the examples that I'm going to show you now demonstrate some simple uses of the for loop. These aren't real-world examples, but they do show off some of the issues and options that you'll encounter when creating loops. Imagine that a system requirement for your application is that you need to display a number of items using sequential numbers from 0 through 10. So I'm going to go ahead and run this code before I talk about it. And M for loop 1. And that shows what I need to do. I have to display item 0, item 1, item 2, and so forth. Now, in reality, I'd probably have some other text next to this doing some of the thing, but bottom line is that I needed to display 11 items like this, the numbers 0 through 10. Okay, so that's what we need to accomplish. Here's some code that you could accomplish that with. I could use a while loop. I declare and initialize the variable I to 0, and as long as I is less than 10, I write out item whatever number, and then increment I, and then it goes through, and as long as it's less than or equal to 10, it executes this code. Once it hits 11, it drops out and executes the next line of code after the loop. But I could do the same thing and simplify the code using a for loop instead. So that collapses this code down to just this. So I'm saying for int j equal to 0, so that's declaring and initializing the value, as long as j is less than or equal to 10, and then I'm going to increment j at the end of each loop, and I write out that value. So both of these loops produce the same output that I showed you. But comparing the two snippets, you can see that the for loop lets you write simpler, cleaner code to do the exact same thing. The for loop, in essence, is taking care of much of the loop's housekeeping duties for you, such as testing the loop condition at the appropriate time and incrementing the loop counter variable. Now, frankly, the hardest part of using the for loop is defining the loop conditions. The good news is it's not hard at all, but if you're not used to it, it's a little bit funky. So each loop statement consists of 3 parts: the initializer, the condition, and the iterator. The initializer sets up the loop counter variable, which was I in the first code example that I just showed you, and j in the second. This takes care of both declaring the variable type and initializing its value. I initialized it to 0 in the example, but you can initialize it to other values as well. Okay, but the important point is that it both declares and initializes the value. And it does this only once, regardless of how many times the loop repeats. One way to think of this is that it happens immediately before the loop starts. So however you want to conceptualize it, but it's only going to happen once. All right, then the second part of the for loop is the condition. Now this is similar to while loops. And this part defines the condition that determines whether the current iteration of the loop executes. And like a while loop, if the condition is not met for the very first loop, the loop never executes. And then the third part is the iterator. As each loop completes, this part of the for loop statement determines what happens to the loop counter. Now the samples that I showed you both incremented the loop counter, I and j, but you can change them any way that you'd like. Keep in mind that this operation occurs at the end of each loop. So in both samples, the loop executed for the first time with the loop counter set to 0. Now, the first and the last part of the for statement, the initializer and the iterator, those are both actually statement blocks. And that means you can place multiple statements in the block, separated with a comma. And actually, both these parts are optional, although you still need the semicolon delimiters. This is an advanced technique, and it's beyond the scope of what I'm going to show you here. But it's nice to know that that kind of functionality exists, and there are times when it comes in handy. But you can't place multiple statements in the middle chunk, the condition, the termination condition. In other words, you can only have one condition that can control the loop execution. But you have lots of flexibility in how you define the for loop. But it'll be fun to play with once you feel comfortable with the basic loop syntax, to play with the for loop and the interesting things that you can do. One of the variations that you can do with the for loop is that you can increment the looping variable by any value you like. So, for example, by specifying an increment of 2, you visit only other value. By specifying an increment of -1, you loop backwards. So here's some examples that demonstrate some of the variations that you can do. So here I have a for loop. I'm declaring and initializing the integer value I to 0. I'm going to loop as long as I is less than or equal to 10. And I'm going to increment by 2. Okay, so I'm going to start at 0, then go to 2, then go to 4, and so forth. And then I write out that value. And notice that I'm using the write method of the console, so this statement is not going to put in a carriage return line feed. But I have a little space, so all the numbers are going to be on a single line. I can also loop backwards. This time I'm declaring and initializing the variable to 10. I'm going to loop as long as I is greater than or equal to 0, and at the end of each loop I'm going to decrement the loop by 1. And once again, write out those numbers. So I'll run the code at this point. This is n. And there you can see my results. 0, 2, 4, 6, 8, 10. So I'm incrementing by 2. Here I start at 10 and go down by 1 backwards. Okay, so now this raises the somewhat interesting question of what is the value of a looping variable after the loop? Now, if you declare the variable in the loop, as I've done here, the value of I is not available outside of the loop. So the scope of I in this loop right here is this code block, just the for statement. But I can also declare the variable outside the loop before I start executing. And now the loop is going to change the value of j, but the value of j is going to be available after the loop is completed, and so I can display what the value is. In essence, this loop is going to work with respect to the variable. It's going to work the same as a while loop, where I needed to declare the variable before the loop counter variable. If that's how I'm doing a while loop, I needed to declare it before I did the while loop. And then for a while loop, it's also available afterwards. Okay, and if I go back to my results, I can see that I go through the loop 5, 6, 7, 8, 9, 10, and the value is now 11. Now it's important that you understand why it's 11. Because if you stop to think about it, it really should make sense. Keep in mind that the loop executes the iterator expression, this expression right here. It executes it at the end of each loop. And that new value is used to determine if the loop should execute again. So this is going to execute until the value is greater than 10 in this case. In order for the value to be greater than 10, I'm incrementing each time. It's going to terminate the loop when the value turns 11. Okay, so make sure that you understand that behavior. All right, and this is an interesting example because it shows that you can nest loops to any depth you like. So I have this outer loop where I'm using the variable I. I is going to go from 1 to 10, iterating by 1 each time through the loop. And then the inner loop is going to iterate from 1 to 5, incrementing each time. And it's going to display the product of I times j. Now, one of the things that's interesting about this is that because this loop is within the outer loop, I is in scope here. And so what I'm doing is displaying the product of I times j. And I'm going to pad the value so that the numbers line up. Okay, so first time through the loop, it's going to execute. Come to this loop, this will execute 5 times. And notice that all the numbers are going to be on one line. And then I execute the right line after that loop is completed. In other words, once it's greater than 5, once j is greater than 5. I execute this next loop. I is incremented, it's now 2. And so it executes this loop again. J starts again at 1, goes until it's 5, or greater than 5, and displays those values. That's for loop 3, which is O, and there you can see my table of numbers. So for the first row, I is 1. So 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3. Second row, I is 2, and so it's multiplying each of the values of j. So I times j here is 2 times 1, 2 times 2, 2 times 3, and so forth, all the way through that column of numbers. And you can also see why I padded by 4, because the biggest number is 2 digits, so that gives me a couple spaces in between. All right, and then the other thing to understand about this is that because this loop is going to, the outer loop is going to execute 10 times, and the inner loop executes 5 times for each of those loops, altogether I have 50 numbers that are displayed in the console window. The nice thing is that the amount of flexibility that you have with the for loop is actually pretty surprising. Given the relatively simple syntax of initializer, condition, and iterator, you can perform a lot of customizations. Be sure to think outside the box too, such as declaring loop counter variables before the loop to take advantage of the value after the loop, and experiment with complex conditions and expressions for the iterator. You're not limited to using variables and literal values in the expressions either. The idea is just bend the for loop to your will. Again, don't go overboard because you can really write obscure, hard to maintain, buggy code. But you can get very creative with very clean syntax that still conveys exactly what you're intending to do and make the loop very efficient. It really is a fairly elegant structure in C#. Another cool thing that you can do with loops in C# is that you can use loops to iterate through collections of objects that the .NET framework returns when you call some of its methods. For example, the driveInfo class provides a getDrives method. This method returns a data structure that contains multiple items, one corresponding to each of the available drives on the computer. If you want to iterate through all of the items in the data structure, you can refer to the items by their position within the data structure itself. The data structure that the getDrives method returns is an array. Now, I'm not going to spend any time on what arrays are, but I will mention that the concept is generally pretty simple. If you haven't encountered it before, an array is just a collection of objects, all of the same type, that are addressable via their position within the data structure. All right, so the listDrives method here demonstrates retrieving the array from the method and then iterating through the elements of the array to display them and some information about them. Okay, I'm going to run this so you see what it does. listDrives with for loop, P. Takes a few seconds. And then you can see that on this particular machine, I have a C drive. That's my main Windows drive. It's unpartitioned. And then I have an X drive, which is actually a drive mapped to a network share. So I have 2 available drives that are available on this machine. All right, and as you can see, for each of those drives that it discovered, it gives me the amount of space free on each. Okay, so the code starts by declaring this drive info array. So this is going to hold an array of drive info objects. And I go ahead and initialize it using the getDrives method, and that returns a drive info object for each of the drives that are available in the system. So as you saw, I'm going to have 2 items within this array. And these square brackets here is how you define that this is going to be an array. This is an array variable. Other programming languages that you may have used parentheses for that, and there's other syntax as well. In C#, an array uses square brackets. Okay, next thing up is to declare the for loop. So it's going to loop through this code enough times so that it can visit each drive in the array. And so the condition is based on the length of that array. And that's just the number of drives the drive info found in the system. And an array is 0 based, and so I'm initializing this to 0, and I'm going to increment it once each time through the loop. Okay, and then again the condition is as long as I is less than the length. So it's going to process all the drives and then drop out. All right, then within the for loop, it assigns the value of the current drive to a local variable. And it uses the loop index here in order to grab that instance of the array. So the first time through the loop, I is going to be 0, so that's going to be the 0th array element, the first element in the array. All right, so I'm extracting just one element out of the array. And in this case, this is not an array, it's an individual drive. It's looking at just one of the drives in my system. And this is a very common pattern to have the collection be plural and have the individual item within the collection be singular there. But you can name those anything that you want. Floyd for one and Ann for the other. If that makes sense to you, go for it. All right, next it checks to see if the drive is ready. And if it is ready, it displays the drive name as well as the total free space. And that's just using properties of that drive object. Now, one caution about writing code like this, and in fact it applies to most ways that you do loops. The for loop only checks its endpoints as it starts up, at the beginning here. If the size of the collection that you're iterating through changes as you execute the loop is not going to be aware of the change. In other words, it's not re-executing get drives to get updated information every time through the loop. You could do that if you wanted. It'd be kind of some convoluted code, but you could do it. So if the collection grows, the code isn't going to access those new drives. So if this is a really long bit of code that I executes in here that takes maybe 10 minutes, while it's executing, I go in and add a drive. That would be problematic from a hardware and Windows standpoint, but let's run with it. Let's say we could do it. Then it's not going to know about that new drive. It's going to get the drives there and then loop through just those drives. But similarly, it can cause a problem if while this is executing I took out a drive, or if a drive became unavailable for some reason because it had a hardware problem or loss of power or whatever could happen inside a machine. I'm decidedly not a hardware person. Give me software any day. Then it may attempt to do something with the drive that no longer exists on the system for all intents and purposes, and so that could cause an exception. Okay. So yeah, this is hardware sort of stuff, but there's also software where that could apply as well. Maybe a user deletes something off of a form and you're iterating through all those items on a form. Yeah, there's lots of scenarios where that could be a problem. So just be aware. For loop only checks its endpoints as it starts up. Okay, so that's one way of iterating through a collection of objects that are returned by a method in the .NET framework. So as you saw in that previous example, you can use the for loop to iterate through all the elements of data structures. This technique requires you to keep track of the endpoints and to manage the index yourself. C# provides a technique that allows you to iterate through elements of a collection without all the extra work. It's called the for each loop, and it does the job by starting with the first item in the collection and looping until it has passed over all of the items in the collection. Here's an example that rewrites the previous sample code that loops through all of the drives in the local machine. So here's the for each loop, and it uses a drive info, so it's still using this object to get access to each of those drives in that collection. So the way the loop initializes is that it gets all of the drives, and then one by one goes through the collections which is going to be within this array. And this is each individual drive in the array, so you can use this drive variable in the loop in order to access the different properties of the drive. And if I scroll back up here a little bit, you can compare the two examples. So keep in mind that I had to initialize the array, call the method, define the correct for loop with all the right sizes and with the right endpoints, and then grab the individual drive, and then finally do this code that I wanted to execute for each drive. So you can see this is a much simpler way to write this code. So clearly, if what you need to do is iterate through an array or any other collection data structure that contains a number of items, using a for each loop really is the simplest way to visit each item in turn. So all this begs the question, why would you ever use a for loop to iterate through the results of calling a .NET Framework method, given that it's so much easier to use a for each loop? Well, you'll find that there are two important reasons to use a for loop. One is that if you need to use a nested loop, you have to use a for loop. And if you need to traverse a list in reverse order, you have to use a for loop. A for each loop doesn't have that kind of control, doesn't provide you with the option of deciding what order to loop through the collection of items. Okay, and so the second reason is really the far more likely reason than the first, that you'll want to use a for loop rather than a for each. And it's important to understand why you might need to traverse a list in reverse order. So imagine that you need to iterate through a list of items, and you need to remove each item from the collection. As you remove the items reposition themselves within the collection. For example, if you remove item 0, the item that was in position 1 is now in position 0. Your attempt to next remove item 1 leaves the new item in place, and you run out of items before you run out of indexes. So in this case, you have to iterate through the items in the collection from the end. Removing the final item doesn't cause any items to renumber themselves, and you can safely work backwards through the list, removing the items. Although demonstrating this technique is beyond what I want to do in this part of the course, keep it in mind as you work with data structures as you're programming. The rule is simple. If you want to loop through a data structure, removing items, you should start at the end and work backwards, and that means using a for loop.